Microsoft implements server-side AJAX using a set of 5 ASP.NET Server controls that are included by default in the AJAX extension section of the Visual Studio 2010 toolbox. And you can see that image there. These controls provide most of the same kind of drag-and-drop, set properties, run the application kind of design experience that you'll find throughout ASP.NET. It's actually pretty amazing how much AJAX functionality you can get from just 5 controls. The Web Page Designer in Visual Studio 2010 does a great job of providing a graphical design surface for building pages, letting you switch back and forth between design and source view. This makes it really easy to use the graphical tools while tweaking the underlying HTML code. Or, if you prefer, you can write raw HTML for the page and check a graphical view of your work as you progress. The design view doesn't support all features of all server controls, and the AJAX controls have slightly less support than other controls. You'll often need to add features using source view within the designer, because there's no way to add some features in design view. Fortunately, though, the HTML that implements the controls is reasonably simple, with full IntelliSense support. So this really shouldn't provide a hindrance once you learn how the controls work. What we're going to do now is explore these AJAX server controls and see how to implement them in sample pages. Let's start by exploring the Script Manager control. Script Manager is in charge of delivering the correct scripts to the rendered HTML page. The browser needs to be able to download these files in order to implement client-side functionality. A page has only one script manager throughout the lifecycle of the page. Normally, you'll put a Script Manager control on the master page, although you can opt to place the control only on the content pages that are going to use server-side AJAX. This control is the sole gateway for delivering all of the scripts to the rendered page, including the scripts that ASP.NET AJAX client code requires, in addition to any other scripts the page requires. So you can add your own custom scripts to the Script Manager control. Now, in the past, you probably registered scripts by using a script element in the HTML source of the page, similar to this example. So myscript.js has some sort of custom JavaScript that is required in order for the page to run. But the problem with using a script tag like this is that it really isn't very smart. Sometimes your script files need to be loaded in a particular order, and embedding script tags puts the burden of correct ordering on you. The Script Manager has some built-in intelligence to do its best to load the scripts in the order that they require. Script Manager has no runtime interface. Instead, it manages the scripts that implement the AJAX features of the page. Often you won't even need to change the default properties. The control will just do the right thing to include the necessary JavaScript for the page. Script Manager also manages the messages that pass between the browser and the server for a partial page update. You can marshal messages by using either SOAP or JSON, which are two of the common web data formats. So let's take a look at the effect that a Script Manager has on a page. I'm going to start out by creating a new web form. So I'll right-click here, Add New Item, and select a web form. And I'll give it the name of Server AJAX. And hit Enter in order to create the new page. I want the page to look pretty, so I'll drag over this styles.css file and add it to the page. I'll change the title element to Server-Side AJAX. And I'll put the same string within an h3 tag within the body of the page. All right, so that gives us some structure to the page. And I'll save early and save often. All right, so very simple page. All we have is static text, static HTML, and we'll view this in the browser. There's the text, and we can take a look at the view source. And there we go. Typical web forms page. We have that hidden element, has a little bit of view state there. There's nothing on the page, so it's kind of surprising that we even have that much view state. But it's fairly simple, fairly svelte, as far as full-featured web pages go. All right, so now let's see the effect that a script manager has on the page. I'll come over here to the toolbox and go down to the AJAX extensions section here and drag a script manager control onto the page. It doesn't matter a huge amount where we drop it, but this is necessary in order to download the scripts that are used by partial page postbacks. All right, I'll save the page and run it again. And as you can see, nothing has changed in the appearance. I haven't implemented any kind of client-side updates or JavaScript or anything. So let's look at the view source again. And notice that all of a sudden I have a lot more stuff going on. Keep in mind that all of this additional stuff in the page, all of these hidden fields, all of this JavaScript, or most of the hidden fields, all of the JavaScript, all of the references to dynamic and static JavaScript, were all added simply by virtue of adding a script manager. All right, I'll continue to enhance this page as we explore the various server-side AJAX controls. But clearly, you're not going to want to add a script manager to a page that doesn't use AJAX. The page would be far larger than is necessary, but including it provides a lot of the infrastructure that's necessary to make AJAX calls from the browser. The default script manager control that you drag and drop onto a page provides a lot of features even if you don't change any of the default settings, but there's a lot more to the control. And in particular, it has various property collections. It has several child collections, including authentication service, profile service, role service, scripts, and services. We're really only going to use script references and service references, but all of these collections are implemented as child controls to the script manager and affect its behavior as well as the script features that it's going to download and make available to the page. The authentication service defines the authentication service manager object that's associated with the script manager, which you can use to log on and off from client script. The profile service defines the profile service manager object, which is associated with the script manager, and it lets you hook into the ASP.NET profile services to customize the website for each visitor. The role service defines a role service manager object, which lets you customize the page and its behavior based on the user's role membership, a very powerful technique in order to customize how the page responds to different users in different roles. Scripts lets you define a script reference collection object of script reference objects, each of which represents a script file sent to the client. That's how you can include additional script files, JavaScript files, that are downloaded to the page. And then services defines a service reference collection object that contains a service reference object for each web service that ASP.NET is going to expose to a client. Here's the default markup that shows the code for a script manager control. It's going to be rare that a single script manager on a page will use all of these features. As I mentioned, more often than not, just the default empty script manager is going to be good enough, but you have a lot of ways of customizing how the page interacts with AJAX. Let's talk a little bit more about the script reference control. You should use Script Manager and script references in order to load your custom JavaScript files. At runtime, when the Script Manager downloads and executes JavaScript, it's guaranteed to load after the client-side framework loads. Here's an example of some code. that is going to load the myscript.js file using a script reference. So that's all you need to do in order to have the script manager download additional scripts. You don't have to do anything to make it download the AJAX, the built-in AJAX files that are required for server-side AJAX features. But you do need to include your own custom files like this. Or alternatively, you can use a script tag within the page, assuming that there's no dependencies of your customized code on the loading and downloading of the built-in JavaScript files. The script reference child control can also load JavaScript files that are stored as an embedded resource in your distributed assembly. If you change the build action of myscript.js from content to embedded resource within Visual Studio, then your script file will compile into the assembly. And this is nice because it makes deployment of your scripts easier because all of the scripts combine into one file. It also adds a measure of security to the scripts. They're more difficult to change as an embedded resource. Web services have become very popular with the use of ASP.NET because the web method attribute is so simple to use. It's just easy to create web services on the server and then access them from the client. If you have experience with web services, the script manager makes it very easy for you to utilize those web services in Microsoft's AJAX. You can add a service reference control to the script manager in order to access your web services from JavaScript. It creates a JavaScript proxy class that is then sent to the client. And then the client-side JavaScript can use that proxy class in order to access the web service. The easiest way to explain this is to see it in action. So let's take a look at an example of using these features. I'm going to create a web service that converts a text string to uppercase and then returns that new value to a web form that updates the original text box with the new uppercase result. So the first thing I need to do is come over here to Solution Explorer and create a new web service. I'll give it the clever name Upper Service. And we get this nice template for creating a new web service, including a sample Hello World method that we can play with if we want to. I'll go ahead and delete that sample method. I'll keep the attribute because we need to decorate it with a web method. That's what identifies this method as something that's available as a web service to a client application. And I'll add the makeUpper function. It'll be a public. It's going to return a string. And I'm going to pass to it some sort of string content. And it's pretty easy to do that. I'm just going to return the value from the toUpper method. That's a nice thing about strings within the .NET framework. They have all these great functions for modifying content. Now the next thing I need to do is inform the web service that I want to make it available as a script service specifically. Notice up here that the template for a web service includes that script service attribute, but is commented out. So I just need to remove the comment marks, and I'll also remove the comment that's immediately above it. And I'll save the file. All right, so that defines our web service. Next thing we need to do is add a web form. And I'll name this AJAX Service. To make all this work, we need a script manager. So I'll come over here to the toolbox and add that. I also need to add a text box that'll accept the user's input, as well as an HTML button that the user can click on in order to make the text uppercase. So I'll come over and add text box here. And then I'll also add an HTML button. Notice that I'm not going to add an ASP.NET server-side button, but that would have the run@, attribute set to server, but I'm not going to execute any server-side code. So I'm just going to directly create an HTML button instead. And I'll go ahead and move that to a new line. I'll switch over to the designer. And there you can see our user interface. Even though the script manager doesn't have an interface at runtime, it does appear within the designer, so you can select it and set properties. And so now what I'm going to do is I'm going to come over here to the services property of the script manager and click on the ellipsis button there in order to add a new script reference. And I'll set the path property value to the upper service.asmx file. All right, so that's going to tell the script manager to create a proxy object that wraps that web service, which makes it really easy in order to access that web service from client-side JavaScript. All right, I'll come back over to source view here. And as you can see, setting that property added that services element as well as the service reference that references that file. And of course, like other web services, you can reference other URLs, other files, use relative and absolute paths, and so forth. You have a lot of flexibility in how you do that. Now I need to tell the button what to do when the user clicks on it. So I'll add an onClick attribute and point it to a client-side JavaScript function called callService. And I'll save that file. Now we need to create that function. So I'll come up here to the head section of the file and add a script tag. And I'll set its type equal to text JavaScript. The first thing I'm going to do within this function is to get a reference to the text box, because I need to both read the value that the user typed in as well as replace the contents of the text box with the uppercased text. So I'll create a variable called text and set that equal to $get. What $get does is it's a shortcut using the Microsoft AJAX client library to get a reference to an element on a page. It's a shortcut to using the getElementById or the various other methods supported by JavaScript and the document object model in order to get that kind of reference to something that's located on the page. So all I need to do is pass into it the name of that control, which is textbox1. And then I want to retrieve the value from that text box. And now it's time to call the web service. And I need to provide a fully qualified name. So I'm going to call it server-side, which is my project name, upper service, there it is, .makeUpper. And I'm going to pass in the text. So again, that's the text that the user has typed into the text box. And I'm also going to pass in a couple of callback function names. Because this is going to be called asynchronously, the code in the callService function is not going to block waiting for a response from the server. So I need to provide functions that JavaScript will call when it receives a response from the server. And I need to provide a succeeded as well as a failed method. And now I need to create both of those. Here's the succeeded, which gets the result that the server returns. And in this case, all I'm going to do is once again use the get method in order to get a reference to that text box, and then assign the result to the value of that text box. So that's what happens when the call to the web service succeeds. Now I'll create the failed function, which automatically gets an error object that you can use to present information to the user about what went wrong, if that makes sense for the application. And I'll just pop up an alert box with that object. And so the user will see the error message. All right, so that's the client-side JavaScript code that we need to implement in order to call the web service. I do want to point out one more time that you need to provide a fully qualified name here, including the namespace of the application, the name of the web service, and then the method that you want to call. Now, if you didn't call the project server-side, if you're following along, then you would need to change this name to whatever the name of the project is, or the master namespace. And you can always find that within the upperservice.asmx file if you're not sure what the namespace should be. All right, so I'll save everything, and I'll right-click on this and view it in the browser. There's our user interface, and I'll type in some lowercase text and click on the button, and I get back uppercase text. And as you can see, it was an AJAX call because it didn't cause a full page refresh. The way this works is that the script manager saw that I added that script reference, and it created that JavaScript proxy object that I mentioned. And this has method signatures that are similar to the method signatures in the web service. Then, the server sends that proxy to the browser with the initial page request, so that calls in JavaScript that reference fully qualified namespace of the method seem to call the web service directly. But in fact, what's happening is that they're calling into a JavaScript proxy object that in turn makes a call to the service with a web request and then returns the appropriate value. The Script Manager control has a script mode property with a default value of auto. Auto will revert to the debug setting in your web.config file. This is a really nice feature for deployment, so that in your production environment, you can set your production web.config file with the debug mode off during the compilation, and the Script Manager will automatically pick up on that value. This is a particularly useful technique with Visual Studio 2010's new support for creating multiple versions of web.config. So you can set all this up once, and then no matter whether or not you're working on your development machine and debugging the application, or if you've deployed it to a web server, either a test or a production machine, then script mode will automatically pick up the value from the web.config, and the deployment process will automatically update that debug value within web.config. So this is the debug setting that you find in web.config. It's in the compilation element, and debug, generally for development time, is set to true. Now both Script Manager and the Script Manager proxy have a script mode that have several options. First, as I mentioned, is auto, and it just uses the settings from the web.config. Debug looks for debug scripts first, and then gracefully rolls back to production scripts. What's happening here is that you can create two different versions of JavaScript files, and most of the files that Microsoft creates and ships have both a debug and a release version. The debug version has lots of white space, has comments, it's very human readable. But the release version has all the comments removed, a lot of the white space removed, and is often minimized in order to create the smallest possible download. Inherit is another option, and this uses the debug mode setting from a parent Script Manager proxy or a Script Manager control. And then finally, there's the release, which renders production scripts. If Script Manager or Script Manager proxy is set to render in debug mode, It first checks for the existence of those special JavaScript files that I mentioned. And those have a name in a particular format, such as myscript.debug.js. The production version of that file would just be myscript.js.